Here we're asked to find a simplified difference quotient for the function f of x is equal to 1 divided by 2x. So real quick, let's recall that a simplified difference quotient is an alternative form of the slope formula. So we know it's going to be the change in the y values by the change in the x values. And here we're thinking about a simplified difference quotient between some point x and x plus h. So the difference quotient is defined as f of x plus h minus f of x all divided by h. So this is the formula that we are looking for here. So we're given the original function f of x is equal to 1 divided by 2x. So the first thing that we need to find is f of x plus h. So to do this, we want to look at our original expression, and everywhere we see an x, we're going to replace that with x plus h. So we'll even incorporate parentheses here for good luck. So f of x plus h is equivalent to 1 divided by 2 times x plus h. And I know I'm going to need to find a common denominator here. If we look at our difference quotient, we can see that we're going to have in the numerator, we have the difference between f of x plus h and f of x. So we'll leave f of x plus h factored. So step 2, finding that difference, f of x plus h minus f of x. This is equal to 1 divided by 2 times x plus h minus 1 divided by 2 times x. So we're going to need to find a common denominator here. So our least common denominator is going to be the product of the factors of our denominator that appear the maximum number of times in any one denominator. So we can see both denominators here contain 2, so that's part of our least common denominator. We also have the factor x plus h, and then we also have this factor x. So we are going, in order to combine these two rational expressions, we need to create this common denominator amongst these two rational expressions here. So for this first term, we notice the only thing that's missing from this denominator is x. So we multiply the top and bottom by x. And with the second rational expression here, we see the only factor that's missing is x plus h. So we multiply the numerator and denominator by x plus h. So this becomes x all over 2x times x plus h minus x plus h all divided by 2 times x plus h. And now that these two expressions have the same denominator, we can rewrite this as a single expression, x minus, use parentheses here for safety, x plus h, and that's all divided by the common denominator, 2 times x plus h. And so we want to simplify a little further now. So we'll take this negative and we'll distribute it through to both terms, which leaves us with x minus h all divided by 2x times x plus h. And so we see we have like terms here that can cancel. Positive x and a minus x combine to 0. So we are left with the simplified rational expression minus h divided by 2x times x plus h. So that's our numerator here of the difference quotient. That was our f of x plus h minus f of x. So our last step here is to take this and divide by h. So last but not least, we need to find the full difference quotient, the full simplified difference quotient, f of x plus h minus f of x, all divided by h. So plugging in what we just found, our numerator is negative h divided by 2x times x plus h, and this is now all divided by h. So to fully appreciate this cancellation, we want to keep in mind that we can rewrite the h of the denominator as h divided by 1. So when writing it like this, we recall that fractions in the denominator will flip, or we're going to multiply by the reciprocal of the denominator. So the numerator still stays the same. This is negative h divided by 2x times x plus h. And then we're multiplying by the reciprocal of the denominator, 1 divided by h. And now this helps us to see the h in the numerator cancels with the h of the denominator, leaving us with 1. And we have a beautiful final answer here of minus 1 divided by 2x times x plus h. And this is the simplified difference quotient.